So today we're going to factor using difference of squares. First thing I want you to notice is that this only works when you have two terms. So before we actually factor, I want you to take a look at this first problem here that says to multiply. We have the quantity of 3a plus 5 times the quantity of 3a minus 5. So we're going to distribute this 3a to the 3a and to the negative 5. So 3a times 3a is 9a squared. 3a times negative 5 is negative 15a. Then we're going to distribute the 5 to both. So 5 times 3a is positive 15a, and 5 times negative 5 is negative 25. Now notice what happens when we go to combine our like terms. Negative 15 plus 15, that's 0, so that cancels out, and all we have left is a 9a squared minus 25. Now look at this problem. If we go backwards, which is what we do when we factor, notice if we look at the 9, what's the square root of 9? That would be a 3. And if we look at the 25, square root of 25 is a 5. So what we're doing with difference of squares is we want two terms that we're subtracting, because that's what difference means, subtract, and numbers that we can take square roots of. So notice our answer is always going to look like this: a minus b and a plus b. Okay, let's try a few examples. So the first example, we have x squared minus 25. So the first thing we're going to do, just like all of the other factoring, we're going to look for a greatest common factor. So this would be a 1 in front of the x squared. So 1 and 25 would just be 1, and there's no variables in common. So next we're going to check for what's called difference of squares. So difference, first of all, means that you have a subtraction sign, which we do here. In squares, we're talking about square roots. We want numbers we can take the square root of. So x squared, we can take the square root of, and then 25, square root of 25 is 5. So the way we're going to write our answer, we're going to put two sets of parentheses right beside each other, and we're going to look at the first term, which is x squared. So when we say the square root of x squared, we just take half of the exponent. So half of 2 would just be 1x, and that'll be the first thing in each set of parentheses. And then we're going to take the square root of the second term, which is 25. So the square root of 25 is 5, and that'll be our second term in each set of parentheses. We're going to make one of them a subtraction, one of them an addition sign. So the quantity of x minus 5 times the quantity of x plus 5, this will be our answer. So let's try the second one. So we have 81a squared minus 49. So same thing, we're going to check for greatest common factor between 81 and 49, and there's not anything other than 1. So we're going to check for square roots, and you can take the square root of 81, which is 9. You can take the square root of 49, which is 7, and you can take half of a squared. So we'll put two sets of parentheses, and we'll start with the first term. So the square root of 81 is 9, and we'll make that the first term in each set of parentheses. The square root of a squared, you're taking half of a squared, half of the exponent, which is 1, a, right beside it. Then we're going to take the square root of 49, which is 7, so that will be the second term. And then we're going to make one a minus, one a plus, and this will be our final answer. Okay, so why don't you pause the video and then try example number 3 on your own. So example 3 says 100y squared minus 1. So pause it, try it on your own, then come back and watch it. Make sure you have it completed correctly. So we'll start with greatest common factor. So there's not a greatest common factor between 100 and 1 other than 1. There's no variables in common. So we're just going to start with our square roots. So you can take the square root of 100. You can take the square root of y squared. We have a minus sign for our difference. We can take the square root of 1. So we'll put two sets of parentheses. We'll start with the first term. So the square root of 100 is 10. That'll be our first factor, or first term in each set of parentheses. Square root of y squared is a y, right beside the 10. Square root of 1 is 1, so that's the second term in each set of parentheses. make 1 a minus, make 1 a plus, and there's your final answer. Okay, so example 4, we have 16x squared minus 36y squared. Now, this one's actually going to have a greatest common factor. So our greatest common factor for 16 and 36 will be 4. So we'll factor out a 4. We don't have any variables in common. So we'll have 2 blanks here. So when we factor out a 4 from 16x squared, 16 divided by 4 will give us 4. Bring down the x squared. Then we'll look at the second term. 36 divided by 4 will give us, or negative 36 rather, divided by 4 will give us negative 9y squared. Now, we're going to look at just the part that's inside the parentheses, and we're going to try to do difference of squares here, because we have this subtraction. We can take the square root of 4, we can take the square root of x squared, we can take the square root of 9, we can take the square root of y squared. So we're going to have 2 sets of parentheses here. The square root of 4 is 2, and the square root of x squared is just x, because you're just taking half your exponent. The square root of 9 is 3. Square root of y squared, half that exponent would give you 1y. We're going to put a minus, we're going to put a plus, and then we're going to carry down this greatest common factor, which was 4, and there's our final answer. Okay, so example 5, we have a to the 4th b squared minus 9a squared. So we're going to start with greatest common factor. So this would be like having a 1 in front of the a to the 4th and b to the 2nd. So the only thing that goes into 1 and 9 is 1, but you'll notice that they both have the variable a. So we're going to factor out a, and we'll actually take the smallest a, which is a squared. So when we factor that a squared out, a to the 4th divided by a squared, you'll subtract those exponents, which will leave us with a to the 2nd. We'll still have a b to the 2nd left. And then factor it out of the second part. So we'll have that negative 9, but a to the 2nd and a to the 2nd, 2 minus 2 is 0, so that goes away. Now we're going to look at the part in the parentheses, and we're going to try to do difference of squares to this part. So we'll have 2 sets of parentheses. So we'll start with the first term, a squared, b squared. So when we take the square root of that, remember with the exponents, you're just halving them. So half of a squared is a, half of b squared is b. And that will be the first term in each set. And then the square root of 9 is 3. So that will be the second term. Make 1 a subtraction, make 1 an addition sign, bring down that greatest common factor of a squared. There's your final answer. Okay, so same thing on number 7. Why don't you pause the video, try it on your own, then come back and watch. So we're going to start with greatest common factor again on this one. So the greatest common factor for our numbers, 5 and 20, is 5. You don't have any variables in common on this one though, so just factor out the 5. So 5 divided by 5 would give us 1, and we'll have that a squared still left. You could put the 1 or leave it off, either way. And then negative 20 divided by 5 is negative 4. So now we're going to look at the parentheses, see if we can factor difference of squares here. So we'll take our 2 sets of parentheses, set them up, and start with the greatest common factor of a squared, which is just taking half of it, which is a. And the square root of 4. Square root of 4 is 2. Have 1 be a minus, 1 be a plus, and we'll bring down that greatest common factor, which is 5. So last example, we have x squared y minus y cubed. So you notice this time we don't even have any numbers to worry about. You can fill in ones in front of both of them if you want to. Or we could just look and say, well, our greatest common factor is going to be a variable. So the variable that they both have in common is a y. And we'll take the smallest y, which is just a plain y. So when we factor out that y from the first x squared y, that's going to leave us with the x squared, y divided by y, so 1 minus 1, that just cancels out. Then the second one, y cubed divided by y. You subtract the exponents. Remember, this is like a 1. So 3 minus 1 is 2. Bring down our negative there. So then we're going to look for difference of square in the parentheses here. So we'll have two sets. We have a difference because we're subtracting. Square root of x squared, you take half the exponent. So half of 2 would be 1x. And square root of y squared, same thing, you do half the exponent. So half of 2 would be 1y, y to the first. Make a minus, make a plus, carry down that greatest common factor, which is y. And there's your answer.